guys. I'm ready if you're ready.
Good afternoon. Our project is called Embedded Photo Booth, and so this is the outline of today's presentation. We'll go through the motivation, the objects first, and then we'll overview the entire project, what we're going to do, and our targets, our objectives, and then we'll overview the technology we're going to use, and finally we're going to introduce the implementation plan. We prepared this before the break, so there might be something that we've done over the break. And so this is our motivation. So a photo booth, I mean, you have on your iPads and your MacBooks, and we got the physical photo booth as well. We were studying in Japan before, and they got something look like this in fancy boxes. And inside you can take a photo, which change your background to something else. And so it's a private box, and can take a photo of the guest inside the box. And the photo is processed with artificial background. They can change you like maybe in the space or you're somewhere else. And the guest can print or download the photos taken inside it. So that's what the photo booth is. So we want to build something based on like the embedded system and the cloud server to implement all these features. So we call it embedded photo booth, and of course, I can take photo. There's something can done basically, and the photos taken by this booth can be uploaded to the cloud server, and the photo can be processed with artificial backgrounds. That's something the same as the photo booth, and the photos in the server can be downloaded by the guest. That's what our objective is: implement this embedded photo booth. So here is our project overview. So we want to build the Raspberry Pi as the processor of the photo booth in charge of the photo taking and the photo process. Let's say we change the background, and we will use OpenCV for this part, and the photo upload to the server. And we will build a small GUI for the guest to interact with the machine to take a photo or select which background they're going to use. We'll introduce this part later. And the photo server, we want to have a built up on Node.js, which is basically just like a file server. It receives like certain photos from the BeagleBone, and the guest can download these photos from the server. And the MongoDB part is here how we want to implement this. So the user takes a photo. The Raspberry Pi generates a random series of letters and numbers to the user. And use this code, you can retrieve this your files from the server. So that's where MongoDB kicks in. So there's a file and the name. If there's a code matching, they get the file. If there's no code found, of course, you get nothing. And finally, we will have a browser client for the user to retrieve the photos and also select which photo they want to download. So we will go through this part later in detail. And so here's basically the three components we have. So first is a Raspberry Pi based photo booth. We have a touchscreen interface, and we want to offer two photo taking modes. One is on demand. Basically, click button says we want to take a photo, take a photo. And the second one is movement detection. It's just standing there, and it senses a movement. Maybe by some margin, it takes a photo automatically. And artificial backgrounds, which is change the background to some fancy backgrounds, maybe the spice or some other things. We'll give several options. And the Raspberry Pi uploads a photo to a cloud server, and with a random generated key for clients to retrieve the photos. That's what we mentioned before. And the cloud server is they have two parts. One is for storage, and another one is a photo key database, which is for user to retrieve the files. And the web browser client allows the user to retrieve the photos using their keys. So that's how we want to make these three parts work coherently.
Let's turn the lights down a little bit so the screen is a little more visible. Button 3.
So a basic overview of the things we need. On hardware side, we need a Raspberry Pi 3. We already bought those. and the Raspberry camera module, which is for the user to take the photo. And we need the Raspberry touch screen basically for the user interface. And also we want to have a chroma key curtain, which is for easier photo processing, because otherwise there's sometimes, we still have a slice of the real background in the artificial background. And we found it really cheap, it's like 20 baht on Amazon. And for the implementation detail, so the user interface, we want to use the Vixie Python, which is something very makes implement a GUI easier on the embedded system. And the photo capture, we want to use Python and using the PyCamera, which is a library for the Raspberry Pi exclusively. And the mode detection, we want to use OpenCV. The reason we choose C++ because we want high performance. We don't want to like 10 FPS for the real-time action. And the artificial background, also want to use OpenCV and C++. And the file upload over HTTP, we choose Python to implement. This one is quite easy. And for the cloud server, for the file server, we use Node.js. This is very popular, and we all use this in all our projects basically. And the key database, we will choose MongoDB. And the web browser line basically is HTML and CSS for the design. So that's basically our implementation overview. Here's a Raspberry Pi. I think we have like noticed quite frequently these days is it's got a quite powerful processor, and the reason we choose this because we already have a bigger one. But the cost of adding another Wi-Fi module and the USB hub is even, I think, is somehow on par with buying a new Raspberry Pi. So we switch our platform to this one. It goes on board Wi-Fi and Bluetooth and 4 USB ports. And the reason we're interested in this one because if the Pi camera doesn't work as what we expected, we can switch to a USB camera. And we have tested this one on bigger one before. And I have 40 GPIO pins and the HDMI support and everything else we need for this project. So that's the camera module. It has very high resolution, even though in our test recently, we found we can achieve by maybe 480p to the best because sometimes it's still not that powerful processor due to all the processing behind the scenes. And for the Raspberry touch screen, I mean, this one is very good. We put everything in one module. You got the 7-inch display for the user to interact with the Raspberry Pi and the camera part. And then if we start some technology we're going to use for this project, the first one is Vixie Python. It's basically just a GUI toolkit and allow us to create GUI using Python. And basically, this one implement Python is an extension module. It wraps another GUI library, and the big part, the very best part is open source. The other option we have, I think, is IQT, but we heard some hard to implement stories on that one, so that's why we choose the Vixie Python over that one. And here's some basic examples. Basically, it's like writing a GUI in Python. And this one comes from the Vixie Python website. It teaches us how to create a very simple window, and it somehow reminds me of what we write in the old days. Like
Yeah.
it feels very similar, but much more
It's
easy.
using Qt underneath, I think. And,
Okay,
and that's an old that.
Yeah, but it's much more easier. I mean,
Yeah,
it's
sure.
not,
Because Python put some nice wrappers around it.
Yep,
Yeah.
yep. So so that's how it looks like. So we will implement a very simple GUI. I think it's the next. This is the thing we want to implement. So this part shows the photo, or the photo will be taken, and they have two modes. One is capture, one is auto. This one is like a radio box where you select it, is automatic taking everything, and there are three like effects, like different backgrounds. Maybe this one is space, or maybe add something to the background, add a cat or something. That's what I suppose. And there's a set button, means send all the pictures taken in the zip file to the server. So we would like to use with Vixie Python to implement a GUI like this one. For the, I think it provides enough user interaction for user to use as a photo booth. And another thing is Pi camera, as mentioned before. This one is for a pure Python interface to the Raspberry Pi camera. It's a lot easier to use. I mean, for the capture function, I don't think is have any difference between the OpenCV capture and the Pi the Pi camera capture. But since we're using the Pi camera, so that's why we're using this library. So what we'll do with this is very simple, just capturing picture. Because all the processing we will use OpenCV and C++. And OpenCV, and this is a very important part in the embedded part of our project. So basically, we all heard before, it's a library of programming functions for real-time computer vision-related tasks, basically just the image processing from our end. And the primary interface is C++. That's what we also use for the real-time performance. And based on my research and my experience with BeagleBone before, I don't think the most up-to-date OpenCV 3 is quite available on these embedded platforms. You have to compile it, and it takes a long time. But the other box, these things support OpenCV 2, which provides, I mean, more enough function we would like to use. And here's some very basic example of what we can do with OpenCV. Let's say this is an original image. We can get the grayscale of it. We can get the threshold binary. Basically, just there's a threshold smaller than this is 0. Larger than that, that's 255. And the adaptive binary is based on thresholds is select like within these neighbors of pixel. And the edge detection, there's some, these are pictures are all generated by ourselves to see what OpenCV is. And it's just like 1 or 2 lines of function is very useful and convenient to use. And here's something we would like to implement. We already completed the motion detection task. We will present maybe in the second one. And the other thing we want to use OpenCV to do is actually to change the background or add something to the picture, just like this one. So one way we try is like there's some function can extract the background from the series of pictures. And we use this to create a mask. So that's sort of the picture. We got the mask, and we got the inversion of the mask. And we apply this background. It's like a cutter. Cut the inside out and just have the leftovers and combine the picture together. So that's how we want to implement the second part. For the motion detection, basically, we use the grayscale, the binary image, and also the background, and to do an image-wide subtraction. And then we count how many zeros in the picture. If it's greater than the threshold, then we assume there's a motion by the user, then we take a picture. That's how we implement those two parts, the functionality of the photo booth. And then I'll switch my partner, Jing, for the rest of the part.
Hi, I'm Jing. I will continue to talk about the technology overview of our project. And first, I will talk about Node.js, which we will use for our file server. And as other students have already mentioned, Node.js is an open source cross-platform JavaScript runtime for executing JavaScript code server side. As we all know, that JavaScript is usually used at the client side, as this picture shows. Client will send the request to server, and server will use, for example, in this case, PHP server language generated the requested HTML and response to the client. And the JavaScript will run the response HTML and show the content to the client.
Since you're using Node, why not use Express instead of PHP? So Express is a Node module that basically builds a web server.
We did use Express and the Malgate for file upload.
Yeah, I just
this is the example we will introduce those in the later slide.
Yeah.
We did use the Malgate, I think, and
this is not what we want to do. I just want to explain what's the URL code. And so for Node.js, it just enables us to run the JavaScript at the server side. So it's more quickly and more
I just didn't wait long enough.
Yeah, sorry.
So
I talked too much about, yeah.
Yeah.
So there are many advantages of the Node.js, and among those advantages, I pick up two that related to our project. So the first one is that Node.js will enable to create fast upload system, which we will use to upload the which take. And also the second one is will respond to numerous requests efficiently in real time. For maybe we have multiple clients which who want download their picture or want to upload it. So Node.js is fast because it's based on the non-blocking model. We have a simple example here and show that we define a callback function and save the function into a variable. And so this function will not run until it is called. So we pass this callback function as a parameter into this request function, which in this case will upload the file to the destination. So when this code run, we can see that first it will handle with this request function, which will upload the file, and then it will be ready to take another request, which in this case will print out this message, which is do something else. And this will continue until the upload file is done and will show that this message to the console. So this is maybe very hard to understand why Node.js is fast. So we will see to the next example. So in many web applications, is always based on the blocking model, which if we want to upload two files, for the blocking model, we can see that first it will handle with the first request, and you have to wait until the first request done, and then turn to the next request. But for Node.js, which is non-blocking model, we can see the time will save a lot much for uploading the two same files. And furthermore, Node.js is able to generate dynamic page content and also can modify the files on the server and also can collect, add, delete, and change data in the database. So we want our file server to have the following functions, such as save the file to the storage and also save the related ID, which we our client, and also the file path to the MongoDB, our database, and also able to retrieve saved file for viewing and downloading. So we will particularly use this multi-model, which is a middleware for handling the multi-part and form data, and it's also used for uploading files. For this example, the desk shows the destination where you want to save your file to. And for database, we want to use MongoDB, which is a cross-platform, document-oriented database, and also provide high performance, availability, and easy scalability. And we just want to save our ID and file path as this key value pair, and like this code, we will insert it into our database. The last one is about our client browser, and we want to use HTML and CSS, which HTML will work as structure and CSS as style. And we want to first have this kind of web page where called get your photo, and client will have to input their ID in this input box and press the get button, and we will retrieve the data in our database and just showed all the picture related to the ID and present here. And client will able to whether select the picture he want or simply press the select all button. And when he or she press down, all the picture or the select picture will download. And for the implementation plan, what we have done, we have already done the project design, setting up Raspberry Pi, and tested the motion detection algorithm. And also on this part, we have simply setting up the file server and Reggie have already designed and test all the image. And we are now working on this part, which I'm now implement the server and database, and Reggie test and implement on the Raspberry Pi, and we'll continue. That's our plan.
Any questions for these guys?
Are you guys trying to make a run for their money for this industry?
No, I don't think it got that much processing power, but we'll try to see what the end product looks like. Currently, what we have for the artificial backgrounds, what we have achieved so far, it looks like less than 30 FPS. Not very smooth sometimes, and even lower than that. So yeah, probably, but we saw some project looks like this before, just implement they call it the something about the system. But we're not. But we'll see what the end product looks like.
The reason I ask is although some of us may see the Philippines already, and it's a very popular product, but the implementation, I mean, I'm guessing that it's very similar to what you're doing.
Yeah. It's somehow similar, even like sometime you visit some place, they got this huge camera. Remember replace the brightness. That's what we got in
I have a question. This is a video stream, right? And you are converting it to frames.
Sorry,
I just had a question about the image processing part algorithm which you're using. So in the beginning, it's a video stream, right? You grab a video stream.
no, we don't grab any video stream. We just indefinitely taking photos, capture picture, save to the file with the Pi camera module, and the rest of the part of the processing is done by the OpenCV part inside it. So we're not doing any video stream.
The motion detection part is part of the.
It's also like we are capture like all the consecutive frames of a certain event, and we compare the backgrounds to subtractions. See if there's a huge difference between them. Video stream is quite hard to test on this thing. I don't think it's quite achievable. Even
That would be a big job.
Even
Yeah.
what we test so far for the frames, like even if we try to change the background, we are not achieve very high FPS, and we are now on 480p. It's not very high resolution photo either. But we are still trying to see if there's any further optimization can be done in this part. Or maybe another trade-off between the FPS, how smooth it looks like, and the resolution of the picture.
It's interesting to see what you can do with that, the platform limitations that you have.
Yeah, exactly.
I can give one suggestion. You can try Hadoop. Have you tried looking into Hadoop? Image processing.
No, sorry.
You can just try it out. You can just check it out what it is. Hadoop.
Okay.
ADOOP. So it's available with Java itself. Like it allows you to split your processing into parts and parallelize those processes together. I mean, you can check it out.
That's a big job.
It's interesting to try.
Yeah. A lot of people are throwing Hadoop at problems, but it's one thing to throw Hadoop at it, and another one to really use it effectively, I think. Yeah, that's really interesting, but I think it's a big job. One project, I think it was 2 years ago, seriously attempted that, and they only got partway there. There was a whole bunch of configuration problems they ran into, and then, it's easy to say split it into parts, but.
I've already done that.
Have you?
Yeah,
Okay, good for you.
I mean, you can split all the different steps, background reduction, other two steps.
If your problem divides up into parts really nicely, that's.
I mean, it's not like we wrote all the code. It was open source. We did have a lot of help. In this case, I don't know.
Thank you, guys. Okay, so. Hey, John?
Professor, is there any computer I can use? I don't think I had the port.
So you don't have a, do you have a display port?
I don't think so.
Just
the
cable
USB.
Type C.
The only thing you have is USB? Then I
Type C.
don't know
I
that.
can give you a flash drive. So I can use this.
Probably, yeah, you can use that one. Yeah, because I don't think.
I have
You got it.
another. Oh, that's display port.
That's not a display port.
No, that's a display port.
This one?
Yeah, I think that's.
I'm not sure.
I have a
It's
decent.
Type C. But your display port. They could. No, I have this one.
Oh, okay.
I can look around it really quick.
See if we can. While he's running, I'll see if my display port works. Oh, there's actually, I think there's might be one. I think there's one right here in the box, in the drawer. There was one of those in the drawer.
Just threw it off my desk.
Okay, let's see if we got it. Fantastic. Yeah, we got it. Thank you, Eric.
Okay, so everyone, good afternoon. My name is Wei Juan, and the project I'm working on is the cross-platform GUI. And this time we're taking a web application approach. I mean, since we're using like Chrome and HTML, this stuff like that, so I just think why not just build a web application. So here is the agenda. I'm going to first introduce what exactly are we going to do in this project. And second, we're trying to have a thorough walkthrough of the technologies we're using. And finally, the tasks, the specific milestones we're having, the plans we have. So basically, we are trying to build a GitHub, which I believe everybody has been using once in a lifetime. Once in a while, so it's a very nice community. I mean, you could share your code, collaborate, everything. Everybody loves it. So what we're trying to do is build a, not exact, but trying to replicate, build a clone of GitHub. So the features that we're trying to make it cross-platform, both for the users of our website and for the developers. We're gonna. So the technologies. So here's the list of technologies: Steps.NET Core, Entity Framework Core, and all those things we're gonna introduce. Not all of them, but just focus on. So first, ASP.NET Core. I know there's been some .NET, ASP.NET around for quite a few years, and this is a relatively new thing. It's a completely re-implementation based on the old ASP.NET framework. It's firstly, most notably, it's cross-platform, better performance, because it's open source. You see the repository on GitHub. And so compared to the traditional ASP.NET, it's obviously cross-platform, and also in the original ASP.NET, you have a few ways of constructing your website using web forms, MVC, web pages, and all, and core supports a subset of that. But most notably, the new thing is the Razor page, which is what we're going to approach. We're going to take in this project, and we're going to talk about that later. And of course, since it's cross-platform, you can develop it on any platform operating system you want. But it doesn't support VB.NET, so I don't think that's much of a problem right now. And again, it has better performance compared to ASP.NET. So the overview, when you have a ASP.NET application, your code does not directly communicate with the client, but rather you start up the process and there's an in-process server. There are it ships with two kinds of server implementations. The first one is Castro, and the second one is HTTP sys. Basically, the Castro is recommended default way for the server implementation because it's cross-platform and better performance. And otherwise, if you want to use some features that's only supported by HTTP sys, you can use that, but that's only available on Windows. So basically, your web server is surrogating as this job. It relays HTTP message back and forth between the client and your application code.
What is it that HTTP sys gives you that Kestrel doesn't?
There are some features. I did not dive much into that, but there's some features that's only supported, and it's only available on Windows. So when you create a simple ASP.NET core project, this is the basic structure. So you have www.root, which is the folder where you put all your static resources like CSS style sheet, your images, your JS files, and you have models, just where you put your data models. And pages is what default place for the Razor page. So the Razor page is different from the traditional ASP.NET MVC. It's rather a VVM pattern, which stands for model, view, and view. Kind of different. And you have a list of Razor pages. Every Razor page is by the C# code. This layout page is where you put your common.
So you're going to write this in C#?
Yes, C#.
And so you're going to use the mono C# compiler?
No, it's like the C.NET Core has.
Or has that package already in it?
Yeah, it's
okay.
not mono nor anything. Yeah, it's different. So the layout page, as I said, it has common HTML elements like scripts, headers, and navigation bar and so forth. And you down here you have your programs, which is to start off the hosting. And you have startup, yes, which So in the startup class, you have two important methods. The first one is configure services. So the configure services is related to the dependency injection pattern that's used throughout the ASP.NET Core project. So basically, what it does is that instead of the traditional way of managing the dependencies through, like, for instance, a class use some other object, instead of directly instantiate the object, it's provided by some other things do it figure out the text you want to do. So that thing to like injecting the dependencies and resolving dependencies is responsibility of the IOC inversion of control. And of course, the ASP.NET Core comes with this built-in IOC container. Here, what you're doing is you are configuring the IOC container, and you can add the framework built-in services, and you can register your own services. And the configure method is where you set up your middleware components. So every middleware component is used for handling the HTTP request pipeline. So it does some computing and either over the execution of the next component or pipeline. So here we are setting up the default routing path, and we're using static files. And then here is the most simplest razor page. Sorry. So you can see one of the features of razor page is that you can embed your code directly into the view. And also, this is very simple, just a very simple form or field. And notice here you have this very strange attribute, which is actually back helper. The ASP.NET Core's a way of providing you to set up views of your render. So what this does is that it plays the validation errors. And of course, there is another tag helper as before, and this part is a expression, C# expression for the first string. What it does is that it automatically generate the name type field for you. And notice we don't have like body, header, because all those things are in the layout. Separated. And so here is the page model, which is the CS file. So as you can see, this also employs dependency injection. It requires a application database context. So it's going to be injected by the IOC. And you have a customer, which is a data model. Very simple. It just has one field called name. Find property allows us to have two-way data binding. So basically, when you submit the form, the name of the customer is going to be bind and made available to our code here. So, and we also have this handler. Very simple. It's just going to check whether the model is valid. If it is valid, it's going to add the name of the customer to the database, which uses the entity framework core, and direct you to. So, what we're talking about just now is all the server-side rendering. So we want client-side dynamic rendering too, because all those specific messages back and forth is. So view is our option here. So it's like similar to Angular and React, but it's relatively lightweight and it's a progressive framework, which means that either use it as a modern substitution for jQuery for like a JavaScript library, or you can also scale up using the routing features to build a single flexible. Here, one of the features, very likely, it also like implements the idea of MVVM pattern. Means that like the Razor page, you can embed JavaScript expressions directly in the view. So this HTML element is just a very simple. This we have attribute which is the called view v4 takes everything in the to-do list. To-do is just declare view instance for some items. So this is that for every to-do item, it's going to direct dynamic all the to-do items using this. Also, this is very interesting because this paragraph and input field. Notice there's a V model, which is another view attribute, which is used to enable again a two-way data binding. What happens is when user input, whenever it types something, that input. And the JavaScript code here declares where it's going to be view instance, methods, and so another notable feature of Vue is the component. Like, its goal is to promote reusability by having your custom, just and new way of managing the parent and child component through these models. This interface that separates these two. So this example shows you how to pass data from your parent child. So this is very similar to a former example. Here we have a view component called child, and it's basically just a span element that shows. So the way that child accepts messages from the parent is through the props. So it accepts my messages. So in the parent passes messages from the input field to the child. Child way this very much. So on the way, the other way that child is gonna talk to the parent is by having the event. So what happens? This view component is basically just a simple button that whenever you click that, it's going to and after that, the child is going to fire a event. Parent is listening to this parent also is going to counter. So the upshot is when you click that button, the parent paragraph also gets updated.
The model that the parent always holds all the state and the child is just responsible for generating events to change.
Right, almost. A child is like passively back to the parent, fire up an event. So since we're building GitHub, so we need Git. But the problem is Git is just a command line tool, which is not available as a library. So what we can do, one thing is that we can start up a process and read line, but it's problematic because it's hard to parse all those outputs from the Git, and also you have to manage the process. So the approach we take is using libgit2, which is really different accuracy implementation. What's so good about this is that it supports a number of language bindings like Java, C Sharp, Python. I mean, it's a long list. It supports everything. That means you can use the libgit2 in any language that of course includes our C Sharp, and libgit2 sharp is the C Sharp, which is what we use right now, and it also targets the .NET Standard 2, which makes it compatible with our. Finally, we're gonna publish, gonna deploy our whole web application to the Azure instead of hosting it on our own. So Azure, as you know, it's like AWS is Microsoft's platform. I mean, it supports, provide a ton of services available. Most notably, at the lowest level, you have virtual machine, which have like completely control over the infrastructure your application is going to run. And at the next level, you have like app services. We're going to use specifically with app services. You have to concern yourself with all those core infrastructure, but you can also like run your application on your own, and it also supports like scaling, auto scaling, something like that. And finally, on the next level, you have functions, which is thing that you don't even have to manage the application on your own. You just write code that's just like serverless. You like just respond to network. So
The infrastructure makes sure you pay as much as possible.
yeah, but the good thing is that they have like free accounts, so you can use
Quick and easy to use, but
it.
might be very expensive.
Right, but it's not very serious. And here are the tasks we have for our project. So basically, the least thing we're going to do first is the account management. We are supposed to enable the user registration, sign in, sign up, and the profile based on users. Also, we have to integrate Git. So on the first level, we can do is you upload your Git repository, and then you view your Git repository. Next level, you can directly interact with your Git repository on the web page, like adding files, editing files, something like that. And the advanced topic would be, collaboration, multiple contributors working on project issues, pull requests, and everything. And the last interesting thing is the social networking functionality, which I don't think GitHub does a very good job at. So our idea is that we can have something like Facebook or Twitter, like a developer can post on things like what I'm going to work on, working on some things like that, and you can also follow some trends and projects you like. I think that's very interesting. So that's everything
So
for my
could you go back to the milestone page? Yeah, so do you have some dates?
It's not exactly, but
Yeah.
I mean, but I suppose I'm gonna.
Milestones really ought to have dates. They're goals for you.
Okay.
So,
Um, that's everything I have. Is there any questions?
any questions for Kai? Hey, John. So have you had experience with ASP.NET Core before?
A little bit, just.
Okay, enough so that you're reasonably comfortable with it?
Yeah, so I actually have, the first demo up and running. So this is just demo now. This is what I've accomplished now, and which is much like GitHub. So I had to substitute this SVG or they're gonna sue me.
Be careful you don't violate
Right.
their
I'll do that
copyright.
myself, but it's just a demo. So,
Yeah.
and here you can like sign in, sign out page. You can sign in. Oops, I'll get substitute. So you can sign in, sign up, and everything, and you can.
All that's packaged with ASP.NET Core, right? Just like it is in ASP.NET.
Okay.
All that's packaged with the core, just like it is in ASP.NET MVC.
What is
The sign-on stuff is it's all done, really.
So yeah, it has a component called identity, which have like
Yeah.
signing, manager, user manager,
Yeah.
stuff like that. It's very easy. Also, you can.
So far, you've done this on Windows only?
Yes, Windows only, but I don't think there's a problem. So
Be careful. Be careful.
All right. But anyway, I'm just
Microsoft makes it sound piece of cake. Oh, you can
Right.
write it once and run it anywhere, and they're full of baloney.
Sure, but since I'm like deployed on Azure, you can see this Azure domain name.
Yeah.
I don't think.
Yeah. I guess you're right. You really, okay, yeah.
And just don't want.
Yeah, everything's running on Azure, so really, you're not doing a cross-platform application.
Right, but
You're doing ASP.NET Core. It's an interesting application, and I'm happy to see you use ASP.NET Core because I'd like to see how capable it is. I've done lots of MVC stuff, but I've never used the core myself. So I know one student last year had a real problem. They were using that student was using Xamarin, and Microsoft said, "Oh, it runs everywhere. Just write it once, runs everywhere," and it was no way. But you won't, because you're running on Azure, you won't have that problem. Any other questions for this guy?
So which Azure?
The app, like web app.
Free one,
And so free, you can sign up for a free account. So it's the app service. It's
Thank you. Let's see, the next presenter is Ming and Zidong. We have 20 minutes left. Is that going to be enough for you? If it's not, we'll postpone you. Think we should postpone? Or do you want to give it a shot?
Me too.
Okay, we'll do it next time. I've got to change the schedule. I scheduled 3 presentations a class period, and it's working out very consistently. 2 presentations per class hour is the way it's working. So, and it really is. We have time. We have time for 2.5 is what it amounts to. But we'll postpone then until Thursday for your presentation. You'll start off Thursday. Okay. Good. Yeah, nod to the heads. Okay. And then, so that means that, Eric, you'll present too, and Fred, probably not. Probably you'll be the next week. I don't want to let this get too long. We're getting close to the limit of the total space we have, so. All right, so let's do it that way. My game plan is, before you guys start the probing presentations, I will give you your grade sheets that I'm working on here. I'm not totally happy with the format I've used for the grade sheets. I'm going to think about it a little bit, but you will see your grade for the first presentation before you start the second.
Will the probing presentations be the same length?
Beg your pardon?
Will they be the same amount of time that we're?
Normally the probing presentations take longer. That's what we've experienced in the past, and I have to think a little bit about how much time we actually have. So what I'll do is, do me a favor and send me an email about that tonight, and I'll think about it a little bit tomorrow, look at the schedule a little bit, and we'll decide whether we're going to do, I'm very inclined, if it'll fit, is just to schedule 2 probing presentations each class. And then we'll probably go a little over on some of those classes, I think, but that's okay. I don't think there's anybody in behind us. I think that's, but you send me the email, I'll think about it, and then I'll comment on it.
Also, for the final presentations on those 2 days, I'm in undergrad classes, so I still have those days. So, do we know what times they're going to be, so I can also have practice?
In your email, mention that to me, and I will definitely. Do you know the time? You don't know the times yet.
I know the time for my finals. I don't know the time because we work around everyone's time. So we leave the next week for ACCs.
We'll accommodate you. Why don't you send me an email just so I remember, but we'll accommodate you, even if it's fairly late notice. We will, it's on those 2 days, and it isn't going to matter to anybody else whether they move up a notch or down a notch. All righty, don't forget Project Ones. You are obligated to turn into Project One. I'm traditionally fairly gentle with late fees on Project One for this class because I know you're busy, but it's time to start thinking about getting them in.
Deadline was April 1st.
I'd have to. I think I said. Probably did say April 1st. Yeah. April 3rd. Is that what I said?
It's a Tuesday.
Another question. You use C++ 17 for the project?
You mean 2017? Or C++ 17, the studio, are you talking about using?
Standard C++.
So are you using, which compiler are you using?
I'm using the file system API that's part of C++.
I'm sorry, I didn't hear.
Using the file system API that's part of.
Oh, yeah. You're using Visual Studio compilers, and you just use setting the options for 20 for the C++ 17. Yeah, I could set my options for that too, so that's not a problem. I haven't because there's a couple of things that of the 14 that don't compile under the 17, so I've left my machine at 17. That's a couple of weird cases, but that's fine. Any other questions before we break?
Yes, sir. So for the project one, that's what's the way to office document.
That was an option, and that requires quite a bit of doing. There's a COM model behind Office, and it's much easier to do in C# than it is in C++. You can import the Word COM interface. There's basically in C# they build a runtime callable wrapper, which is C# on the C# side and a COM of it, and it's fairly easy to do, but it's not very easy to do with C++ client. And I would be perfectly happy if you just did it in your C# client, would be okay. There, all you need to do, you go to it's been a while since I've done it, but essentially, if you open the object browser and look through the namespaces, there's a namespace that you can import that will give you all the Office definitions. You consult Dr. Google a little bit of, access Office functionality from C#, and you'll find the specific namespaces you have to import. But that's a fairly significant task. I think you should, focus on getting the straightforward functionality in at a reasonable time and on your final project before you started doing that.
So we are not required to.
Not required to do that. That was just an option. I thought I made it clear that was absolutely optional. If you're interested, and it was as much telling you that you can do that. Several years ago, we did a case project that we did exactly that. We programmed an Excel spreadsheet for small business that were doing lots of.
For the client, we only required to provide the C++ client, not required.
Didn't I ask for a C# client too? I'm really surprised that if I didn't. I didn't? On the Linux side, obviously you don't, but. It's an oversight on my part, but if I didn't ask you, I won't change the requirements. So let me just pull up hang on a minute while I pull that up. It's actually, quite easy to build a C# client. It's almost trivial, but let's. I didn't. Okay. I won't edit it now at this late date, so. If you decided you wanted to do that option, you would find it much easier. Now, you have to do this, you would have to do it in C++, because it's a text search is a C++ component, so you'd have to do it in C++. And interfacing with the Office library, it's doable in C++, but the interface is really tricky. There's a whole bunch of places where they want a specific construct, variant construct, and it doesn't make any sense other than that's what it needs. I guess I would advise you to forget that. If you wanted to get some optional credit, the LibreOffice is probably a whole lot easier to interface with, be my guess. The only reason I put Office is that Office is built out of COM, and so, you know, you have the opportunity to play around a little bit with it. Microsoft's.
Does that mean in Linux, the LibreOffice provides offers libraries that work directly?
I'm virtually certain that they do. I haven't used them myself. I'm virtually certain they do. But on the other hand, you know, what you really need, you don't really need to interact with Libre. All you need is to be able to interpret their ODF files or whatever the ODs, whatever the file names are. Okay, and they're not using a complicated compound object like COM does. So, you know, my guess is you could probably find a little library reader for ODF files or whatever the Office calls them. You know, at this point in time, I think my advice would be forget the option, just do the straight. You won't lose any points for not doing that. Because it's now, you know, we've got April and a week of March. You got about 5 weeks, and you got the final project to do, and you got to finish off the rest of it.
For the PowerShell,
You could do, so PowerShell, you know, I gave you a bunch of demos. You can look at my demos. But you can do, the requirements are, you could use PowerShell in a very trivial way. All you're doing is running the darn application with PowerShell. You know? So not much more than you would do with a batch file. You can do a lot more. You know, if you put command line arguments and stuff like that, you can do a bunch of orchestrating of tests with PowerShell. And it works really nicely for that, but you're not obligated to do that. Last year, everybody just ran their projects with PowerShell. And it's almost nothing, you know. So in 5 minutes, you can figure out how to do that, and you're done with that part of it. You know, I want you to know about PowerShell, and B, you know, if you're got a little time and energy, I think rather than trying to work with the Office model and the Libre model, looking at PowerShell a little bit would be useful for you. Because there's really a lot of power and a lot of utility in PowerShell. And Wei-Jun, are you going to use VS Code?
Yep.
Because VS Code by default runs you in PowerShell. So knowing a little bit about how PowerShell works can make VS Code, there's a whole lot of things that VS Code can do because of that PowerShell, because its default shell is PowerShell. But you know, what I did when I was using VS Code, the first thing I did was convert it to use the command prompt because I didn't have the time to fiddle around with PowerShell. That would be worthwhile doing. You have no obligation. That was just an option. You have an obligation to do PowerShell and
So it's just with the PowerShell called command line.
you can. That's what virtually everybody did last year. You know, I'd like to see somebody do something a little more, because it's useful, it really is effective, but, you know, you gotta do what you have time to do. Any other questions? Somebody, you know what? We could arrange a bonus, a 5-point bonus for somebody who really did a little more with PowerShell. Okay. Let me throw that out as a challenge, all right? 5-point bonus for anybody who uses PowerShell in a way more effective than just running the application. All righty. See you all on Thursday. Yeah, it's close to Utica. It's a very small
So I don't know how to access.
Oh, salary.
Yes.
Oh. This is a summer internship. Oh, this is full-time? I think what I would do is I would say, you know, I'd like to be paid the going rate for an entry-level developer. Get a review, see what I can do.
Never give them a number.
Yeah. Because if you give them too low, then they're great, they pay you low, and if you give them too high, then you know, they don't. Okay, so you want to do it this week? Sure, absolutely. Just send me an email and I'll swap them. Absolutely. What's enough? I'm already drowning in email.
Yeah, and because I have one to do tomorrow that so I think they might ask you a question.
Yeah, I would just say, you know, I'd be happy with the going rate for travel. Going rate, the standard rate, whatever you normally pay. But I'd like to review in 6 months when you see what I can do.
就上热死一天嘛，热死一天就是说你一天它这个资源在哪里，我就问一下第一个这个资源怎么保护嘛。对啊对。直接 get 的话你没有存在，直接 get 的话。
哇操，这么点！
You have a question? So you are obligated to
The way I wrote the requirements, the COM component, one COM component has to talk to the other COM component. Okay. I would use the same structure there. It's easier in Linux too, but I would just use the same structure. You know, my intent is that you build something pretty close to the same functionality that COM gives you in the Linux platform. So you have an interface, you have object factory, you know, you have reference counting like that. But within, you know, if I were doing it, I would have exactly the same architecture. I think it would be interesting to see the difference in code you write, how easy it is, how well it works with the same structure. You know, native C++ and the other one. It won't be a whole lot, but, you know, I mean, you definitely want to have implementation files. Are you doing everything inline in headers? What are you doing? So you got a bunch of, okay, so you got a bunch of, you got to be careful because you don't want to get you can't make lambdas inline. Yes or no? So let me see. So here's a. Oh, okay, I see what you're doing. So you're doing this all inline in the class. It's a little big to be put inline. Yeah, you should have a CPP file, but your CPP file in this case will just test it.
Can you just remember?
CPP file will just exercise it. Okay, and all right. Are they, so do you have one that's communicating with the other one? Just like the COM one does?
I think so. One is just
so in the COM one, you have to make a call. I wrote it that way to force you to pass the interface pointer through. So, if, you know, in order to do the same, if you're going to keep the same structure, and I really think you should, then you ought to make that same call the same. You know, so, you know, I think you should have an interface and an object factory so that the client is really decoupled from the component. Just like I'm trying to get you to build a real component in native C++. So that means interface, object factory, implementation. So, and now an interface has to be called by, so one component is going to make calls on the interface of it. I think you can do what you're doing, it's just with a little restructuring.